Friends, I Abhinav Negi and Dheeraj sir welcome you all on BYJU'S Exam Prep Civil Mechanical YouTube channel. In this particular video, guys, we both will be doing the complete strength of materials formula marathon. When I'm saying complete SOM, that means all chapters: stress strain, SFD, BMD, bending stresses, shear stresses, transformation stress, torsion, column, spring, shear center, pressure vessels, and of course deflection. Complete formula. But before we start, let me give you a disclaimer that this is not complete SOM revision. This is formula marathon. That means we are not going into the details of derivation. We are not going into the definitions. We are only dealing with formulas, but for complete strength of materials. So please share the session so everyone can enjoy this session. Okay, Sushmita, okay, Karnaji, and Ruth, everyone welcome. Okay, so keep sharing the session so more and more students can belong or can join this session. One more thing, guys, that the PDF, you don't need to write anything. Okay, whatever is written in this PPT, whatever we are writing on here, everything we will be giving you in the PDF form in our Telegram groups, that is Civil by Abhinav sir and Mechanical by Dheeraj sir. Okay, so anything extra which is not written here or which we are not writing here, if you want to write that, it's okay. But whatever written here, we will be giving you as it is. So be ready for the complete formula revision. Now over to the champion, the commando, the boss of strength of material, the person from Hisar, Dheeraj sir.
Thank you, sir, every time for this kind of introduction. So, guys, this session will be very, very helpful for all the students who are preparing for GATE 24 or who are preparing for ISRO 23 or HAL or BHEL, because this revision will be giving you help everywhere where strength of material will be coming as a subject. And I know the August time is going on. This is the time when generally all the students have completed this subject. So this is the best time to revise. And when you revise by yourself, generally we are facing some issues sometimes. But when you are when you are revising the thing with the faculties, definitely it will help you, because nothing will be missed out, because we are going to take each and every formula in front of you, and after that you can directly go to any test of the strength of material that will definitely guide you that where you are making the mistake. So that is going to help you a lot. So if you are facing if you will be feeling that this kind of revision is very helpful for you, we will be coming up for other subjects as well, and just schedule a test after this revision, either tomorrow or day after tomorrow. Then you can also check your preparations, sir.
Okay, so guys, let me tell you that if you want not formula marathon, if you want detailed SOM marathon that we have taken in January of 9 hours approximately, so we'll be sharing the link in the comment box after this session. Okay, so there it will be the complete. This particular session will be dealing with formula, civil by Abhinav sir, mechanical by Dheeraj sir. Let me just tell you that this particular chapter, we will be dealing all chapters. This particular chapter is only for ESC. Okay, this for mechanical also.
For mechanical it is machine design.
Okay, so guys, this white color is in GATE plus ESC both, and this yellow is only in ESC. Now these yellow colors are of from where we can expect only objective questions: column, spring, combined stresses, pressure vessels. You will be mostly getting the objective questions. Now moving further, the stress and strain is double XL. Okay, very large. Okay, then after that, these white ones are XL. Okay, these are double XL. These are XL, means depends on the syllabus. Then shear stress, torsion, and these yellow ones are very, very small. That can be completed one day. Books you can refer Gary Thimshonke. So we are starting with the first chapter first. Okay, so
sir, आप start करिए.
Okay. So guys, again we are telling you that we will be giving you formula here. First of all, this is the stress strain curve. I'm not going into the very detail of stress strain curve because this is a formula marathon, but just want to tell you that initial slope, this is a stress strain curve for mild steel. What is stress? What is engineering stress? Engineering stress is force by original area. A0 is the original area. What is engineering strain? Engineering strain is delta by original length. Okay, and whenever stress and strain is written, that means by default it is engineering stress and engineering strain. Suppose this is a bar, and in this bar, suppose I apply the force. Initially the area is A0 and initially the length is L0, and I am applying a P force. Since we are dealing with deformable physics, SOM deals with deformable physics, here the length and dimension changes, so this will be increasing and area will be reducing simultaneously. So after some time area will be A and length will be L. So engineering stress is force by original area. Engineering strain is delta by original length. Okay. Unless mentioned, if it is only written as stress and strain, it refers engineering stress and engineering strain. What is true stress or true strain? True strain is delta upon length at that particular instant. Okay. What is sigma true? It is force by original area at that particular time, because if we are applying tension, then area will be gradually decreasing. It will not be A naught. Now, if we draw the stress strain graph, this is the stress strain engineering strain graph. Initial tan theta is Young's modulus. Okay, tan theta is Young's modulus. That is, what is Young's modulus? Ratio of stress by strain for uniaxial loading. Guys, stress by strain is not always Young's modulus. Might be many of you are not knowing this. Stress by strain is Young's modulus only when it is a unidirectional load. Okay. Now, moving further, guys, the sigma true value is sigma engineering into 1 plus minus epsilon engineering, plus for tension and minus for compression. And I can give you the logic for this also. Guys, for tension area will be decreasing. So area will be decreasing, A will be less than A naught, A will be less, A naught will be more, so A will be less, sigma true will be more. So for tension it will be plus, sigma true will be more than sigma engineering. When we are compressing, then A naught will be less, but area will be increasing. If we are compressing, area will be increasing. So this will be more, so sigma true will be less. So there it will be minus. Okay. Similarly, epsilon true is equal to ln 1 plus minus epsilon engineering. Okay. Okay. Tan theta Young modulus. Initially for stress strain graph for mild steel, this is linear. Okay, then it is elastic limit. Before elastic limit, if we remove the load, material comes in original position. C is upper yield point. Due to after that, carbon atom slips. So it is lower yield point. Then there is a plastic region. Plastic region means constant stress strain is happening. Here there is no volume change. Here there is no volume change. Then the crystalline structure changes. For further strain, it is not easy. For further strain, you have to increase the stress. Okay, for further, it is not easy like this. For further strain, it requires more stress because the crystalline structure changes, and it changes in such a way that material starts imparting resistance for further deformation. So you have to increase the stress. That is why this is called strain hardening region. Then ultimate stress, and then it is necking failure, and ultimately it's fail. For mild steel, there is cup cone failure at 45 degree. Now, guys, see the complete detail I have told, or we have told in the that we will be giving at the end, that comment, that link. Okay, since this particular session is only with formula, so I'm not going into the very detail of this. Okay, yes, Saga Bhandari. Okay, now, guys, moving further, what is ductile? Ductile means when the failure is after a long strain. What is brittle? When failure is at less strain. Usually, if the post-elastic strain is greater than 5%, then it is ductile. Else brittle. That means the strain after the elastic limit. This is the elastic limit now. After this, if the strain here is more than 5%, then that is a ductile. Otherwise, it is a brittle. Mind you guys, rubber is a ductile material. Sorry, rubber is a brittle material. Although the failure of rubber is at high strain. Failure of rubber which is brittle. This is failure of rubber is at high strain, but still guys, this is a brittle because its elastic limit is somewhere here. So after elastic limit, the strain is not more than 5%. It is less, so it is a brittle material. Usually for brittle material, they are weak in tension. In tension, they fail with very less stress. This is tension, and here I am making sigma compression. But in compression, they take high stress. Okay, they are stronger in compression. Okay, guys. Now moving forward, for different grade of mild steel, now suppose this is Fe250, then we little bit increase the carbon percentage. It will be like this. then we little bit increase the carbon percentage, it will be like this. Now what this mean, that green has less carbon percentage, then after green it is blue, has more carbon percentage, and red has more carbon percentage. Now initial it is almost same, so Young's modulus is same, but which is having more carbon percentage, that is red, can take more stress, but it is brittle. Green has less carbon percentage, it cannot take more stress, but it is ductile, it is failing with high strain. This is ductile. As carbon percentage increases, please tell me on the comment box, everybody, Pejal Word, Manisa, Sushmita, Sagar, everybody, can I say this, that as carbon percentage increasing, total strength increasing, ultimate stress is increasing, it can take more stress, but ductility decreasing? Give me yes or no in comment box. Give me yes or no in comment box, everyone. Everyone, please give me yes or no in comment box. Okay, now stress is a tensor. It is a 3-order tensor, and the stress tensor is written as sigma xx, tau xy, tau xz, tau yx, sigma yy, tau yz, tau zx, tau zy, sigma zz. Okay, I am not going into the derivation in this particular session. Stress is a tensor, 2-order tensor, and it is symmetrical about the main diagonal. This is the mirror image, because this tau xy is exactly same as tau yx due to moment equilibrium, and tau zx is exactly same as tau xz, and tau yzy is exactly same as tau yz. So total number of elements are 9. Total number of elements are 9, but distinct are only 6. Distinct are only 6. Because if we know 1, 2, 3 and 4, 5, 6, then they are the copy paste. If we know this, we know this. If we know this, we know this. If we know this, we know this. So total are 9, but distinct are 6. This is in 3D. Okay. Now in 2D, it is sigma xx, tau xy, tau yx, sigma yy. In 2D, total are 4, but distinct are 3. Because if we know this, if we know this, we know this will be copy paste. Okay. Now moving further, guys, for any element in a SOM, if this is tau, then this will also be tau. Of course, this will be tau, this will be tau due to moment equilibrium. These and these are equal due to moment equilibrium. These and these are equal due to force equilibrium. Okay, if any times anyone say this and this, why the opposite faces shear stress are equal due to force equilibrium? Why the adjacent are equal due to moment equilibrium? This is considered to be positive shear, this is considered to be negative shear. Now, moving further, what does composite bar means? Composite bar means the delta will be same. Even if there is force is acting, temperature is there. If it is mentioned that they are composite bars 1 and 2, and if somebody is applying a compressive force or somebody is applying a tensile force, that means 1 and 2 will be having same elongation. Okay, what does fixed means? If the in quotient it is written as fixed, what does that mean? That delta will be 0. So composite means delta will be same, and fixed means delta will be 0. Now moving further, what is Poisson ratio? So before Poisson ratio, what is Young's modulus? Young's modulus is normal stress by normal strain. It is valid in unidirectional loading. What is shear? This is Young's modulus. What is shear modulus? G, or represented sometimes by C. That is shear stress by shear strain. Now stress you know, force by area. Strain you know, delta by L. Shear stress you know, that is tangential. What is shear strain? What is shear strain? Suppose this is a body, and in this body, this shear is acting like this. In this body, shear is acting like this, and due to this shear, the deformation will be like this. Now, the earlier between the body, the angle is 90. Now, between the body, angle is changed. That is 90 minus gamma. So, whatever the change in angle, that is shear strain. Normal strain is delta by L. Shear strain is change in angle. Okay, that change in angle can be in positive also. Here the angle is increasing more than 90 degree. So shear stress by shear strain is shear modulus. What is bulk modulus? The third one is Third one is bulk modulus. What is bulk modulus? Hydrostatic stress. That means when the stress is acting in all three directions with equal magnitude. So hydrostatic stress means when in a body stress are acting from all three directions and with equal magnitude. Why it is hydrostatic? Because water also exerts pressure at a certain height h, gamma h, and that gamma h is also equal in all direction. Gamma h here, gamma h here, gamma h here. That is why it is called as hydrostatic stress. Whenever stress is hydrostatic on a body, there will be some volume change. This is SOM. This is not engineering mechanics. This is not rigid body physics. This is SOM. So whatever is the volume, delta V by volumetric strain is change in volume by original volume. So sigma by volumetric strain is bulk modulus. Now many will say, sir, if one is sigma and another is 2 sigma and this is 3 sigma, and if sigma is acting only in one direction, then sigma can act in one direction. Sigma can have different magnitude. Yes, it's fine. But bulk modulus is defined for this case only when all three are same upon volumetric strain. Can you tell me the bulk modulus of a rigid body? Can you tell me the bulk modulus of incompressible fluid? Infinite. Because for rigid body and incompressible fluid, volumetric strain will be 0. So this will be infinite. That means higher the magnitude of K. Higher the magnitude of K, it represents that that body is very rigid, it is not liable to volume change. Less value of K means pili body. Volume will change there. Okay. So 1, 2, 3 and 4 is the Poisson ratio, that is lateral strain by longitudinal strain. What is lateral? Suppose in this body, I apply force here like this. Then due to this force, length changes, but other dimension decrease also. So lateral direction is in the direction of force. Lateral is not the bigger dimension. Lateral is in the direction of force. And longitudinal is in the direction of force. Longitudinal strain is in the direction of force. And lateral is the transfers to it. So one is increasing, other is decreasing. So either this will plus, this will be minus, or this will be minus, this will be plus. So one more minus will make it plus. So there are 4 elastic constants for isotropic material. There are 4 total elastic constants for isotropic material. Later on you will see independent are how many? 2 independent. 2 independent, because there are some relations between these E, G, mu, K. There are some formulas. So even if you know 2, you can find with those formulas remaining 2. Even you know 2, there are some formulas I will tell you later on. So you can find remaining 2 from these. Now the value of mu for different material is like this. Mu can be negative also for human tissues and polymers. But mu for metals is more than 0. Maximum mu is for rubber, that is 0.5. Or you can perfectly plastic material. And mu for ductile metals is 1/4 to 1/3. Now, moving further, yes. Volumetric strain of cylindrical bar, longitudinal strain plus this pressure vessels में देखते हैं इसको. Impact loading अभी सर बताएंगे. इधर आते हैं. Guys, now if a P load is acting on a prismatic bar means area is constant. Young's modulus is E and length is L. So delta is given by PL by AE. Deflection is PL by AE. This AE is called axial rigidity. Why? Because if AE is more, this denominator is more, so numerator will be less. So it is providing rigidity. If AE is more, delta will be less. So it is providing rigidity. And if I compare this with a spring, for spring we write P is equal to K delta. So stiffness is P by delta. So from here, if I find stiffness, that is P by delta. So stiffness is given by AE by L. So this is also K of bar. And reciprocal of stiffness is compliance. What does the stiffness physical meaning is? What does the stiffness physical meaning is? More is the K value. More is the K value. Delta is less. For any bar, for any spring, if K is more, that means delta will be less. If K is more, then delta will be less. Okay, got it everyone? Okay, self weight पे भी आएंगे. So delta is equal to PL by AE. Now, if I go deflection due to self weight. So deflection due to self weight, suppose this is the bar, same bar, due to self weight, this is the same bar. Now there is no external force. There is no external force. We want to find out due to its own weight. Okay, this formula is when it is considered as weightless. This formula is when it is considered as weightless. Okay, now if there is weight also, okay, then by default, if nothing is mentioned, always in strength of materials, we assume the body to be weightless. By default, we always assume the body to be weightless. So if there is weight and the lambda is the unit weight, that is weight by volume. Suppose total weight is W, so lambda is weight by volume. In that case, the deflection of this is lambda L square by 2E. Okay, and you put lambda is W by volume. Volume is A into L. Volume is A into L. So you will get here WL by 2AE. You will get it as WL by 2AE. That means if there is a weightless bar, and W load is acting here, this is a weightless, and W load is acting, so deflection is WL by AE. But due to its own weight, if own weight is W, then deflection is WL by 2E, so that is half. So utna hi weight, if the same weight is acting on the body at the free end, then deflection is WL by AE, and due to its own weight without no external load, deflection is half, WL by 2E. And in terms of density, it is lambda L square by 2E. Kahan gaya? Lambda L square by 2E. For conical section, it is lambda L square by 6E. For conical section, deflection is lambda L square by 6E. So we also call it sometimes that here the deflection is 1/3 of this. 1/3 of lambda L square by 2E. Okay. Now, if the area is changing continuously, guys, PL by A is only applicable, this formula is only applicable when area is constant. Okay, suppose area is changing. Here the diameter is D1, here the diameter is D2. Here the diameter is D1, here the diameter is D2. I cannot apply PL by A. Even if you want to apply PL by E, which area will you write here? Which area you will write? Because area here is something else, here area is something else, area something else, area something else. So in this case, deflection we do, and we take a small part and then we do integration. So deflection is P4 PL pi E D1 D2. 4 PL pi E D1 D2. Now if we want to find out a bar having a constant diameter, that diameter is D equivalent, having same length, same material, E. What should the D equivalent so that deflection is same here? So that D equivalent is the geometric mean, under root D1 D2. So this D equivalent, if we put it like this and we apply the load, kahan gaya? Where is the PPT? Where is the PPT? Kahan gayi? Kahan gayab ho gayi bhai? Kahan gayab ho gayi? Okay. Okay. So D equivalent is under root D1 D2. Okay. So that D equivalent is which is having the same deflection as that of tapered bar. Getting this or not? Give me yes or no. Give me yes or no in the comment section. Okay. Now here it is a section which is changing, area is changing, but that change in area is circular. If the area is changing but that change in area is rectangular, at every portion it is a rectangular area. At every portion this is a rectangular area. In this case, delta is given by 4 PL ln B2 by B1. B2 is the width here, B1 is the width here, E into T, B2 minus B1. Okay, suppose a load is acting P and there are two bars having area A1, E1, and below that there is some different material having area A2, E2, then equivalent Young's modulus is given by A1, E1 plus A2, E2 upon A1 plus A2. Now, what is strain energy? see, if I make a graph of P and delta, so more will be the, see, delta is equal to PL by A, more P, more delta, linear. So this area is strain energy. Why this is strain energy? Why this is, what is strain energy? Why this is strain energy? What is strain energy? Why this is strain energy? Now listen. If my cheeks are like this, I apply the load. So when I apply the load, there is some elongation. When I apply the load, there is some elongation. So I am doing some work. F dot D, force into distance. That work has stored a strain energy released. Strain energy released. I am doing some work na. Force into distance. I apply P force. Delta is the strain. Delta is the elongation. So strain energy is P delta. Similarly in bar, if I apply the force and I apply the force, it elongates. Small elongation cannot be visible by our naked eyes. So that strain energy is half P delta. Now you say, sir, work done is P delta na, force into distance. So why it is half P delta here? Because area of triangle will be half P delta. Half base into height. Because guys, in strength of materials, the load is assumed to be static load, not impact load. Once they say that there is static load, means when you are saying the P load is here, and due to this P load, the deflection is delta. So work done is not force into distance. When we say that there is load P, that means that P load is gradually applied. Zero load, then little bit more, little bit more, little bit more, then P load. So for whole delta deflection, average load is considered to be 0 plus P by 2, because whenever in strength of material the load is written as P, it is never P, it is 0, little bit more, little bit more, little, gradually load is increased to P. So for this whole delta elongation, average load is considered to be 0 plus P by 2. So this is the average load. So force into distance. So this is this. Now, so half P delta is the strain energy. And if I make a stress strain graph, consider Hooke's law, so it is linear. So this area is strain energy per unit volume. Very simple reason I have. This is P by A. This is delta by L. So P and delta are making strain energy. P and delta are making strain energy. So denominator is area into length. So here it is per unit volume. P and delta strain energy, I told you. So denominator is, here is A and here A into L. So denominator volume is coming. Okay, so strain energy is half P delta. What is resilience? See, for resilience, what is resilience? Ability to material to absorb energy. Like if you make bike shockers, car shockers. So you want then when your automobile is going into the speed breaker, so shock is absorbed. So more resilient metal is there, that is suitable. So resilience is properties which can absorb the shock. And that material which has more area of stress strain curve up to elastic limit is more resilience. Suppose somebody gives me, Dheeraj sir give me two material. This is one material, material 2, and say Dheeraj sir asks me that find which is good for automobile. Then I will draw the stress strain curve for both the materials, and that material where the area and the stress strain curve up to the elastic limit is more, I will say that sir this is the better material for shock absorber. अब वो गोल्ड है, डायमंड है, सर के पास पैसा है, सर कर लेंगे. Okay. Okay. So that and that area up to the stress strain curve, that area up to the stress strain curve is also called as modulus of resilience. Okay, proof resilience भी उसी कहते हैं. ये सब वही कहानी है. इसके बाद बहुत सारे फॉर्मूले मेरे को यहाँ पे नहीं दिख रहे हैं. ठीक है, बहुत सारे नहीं दिख रहे हैं. तो एक काम करता हूँ, वो मैं यहाँ पे लिख देता हूँ. थर्मल स्ट्रेस के कुछ फॉर्मूले नहीं है. अच्छा, यंग्स मॉडुलस के वाले भी नहीं है. सबसे पहले तो E इज इक्वल टू 2G 1 प्लस म्यू. सर ये देखते रहना, मेरे को याद नहीं है. E इज इक्वल टू 3K 1 माइनस म्यू. E इज इक्वल टू 1 माइनस 2 म्यू. ओके, और एक म्यू का क्या होता था? 3K माइनस 2G अपॉन 6K प्लस 2G, है ना? ऐसे कुछ रिलेशन होते हैं. तभी मैं कह रहा हूं टोटल एलिमेंट्स आइसोट्रोपिक के लिए 4 हैं. टोटल आर 4. E, G, mu k, but independent are 2, because suppose you know any 2, suppose you know this g and mu, so E will be find out. Now mu you know, E is already find out, so you can find k also. So from any 2 you can find all 4. So total are 4 for isotropic and independent are 2. For orthotropic independent are 9. For anisotropic independent are 21.
One more formula, sir. 9 kg.
9 kg वाला क्या था सर? Mu is equal to
E is equals to 9 kg.
E is equal to 9 kg upon 3k
3k plus g.
plus g. Okay. So ये ऐसा है. अब इसके आगे और चलते हैं. तो अगर मेरे पास if I have a body, ये यहां पे कहीं लिखा था, ये suppose this is the stress in x direction in this body, this is in z direction, this is in y direction, then strain in x direction is equal to stress in x by E minus mu sigma y minus mu sigma z by E. Similarly, strain in y direction, sigma y by E minus mu sigma x by E minus mu sigma z by E, and strain in z direction is sigma z by E minus mu sigma x by E minus mu sigma y by E. Now for any of the formulas that we are considering here in this session, if we want derivation, then you can write Abhinav Senegi Poisson ratio or Dheeraj Sardana Poisson ratio. So you will be getting the complete derivation also. Let me again tell you that we are dealing only with the formula. I am not going into derivation of all these things. We are dealing with only formula. Okay, otherwise this derivation we have done many times in YouTube. Now volumetric strain is epsilon x plus epsilon y plus epsilon z. Now if you add all of them, so volumetric strain comes to be, if you add all of them, sigma x plus sigma y plus sigma z into 1 minus 2 mu by E. Okay, this is the volumetric strain. So if sigma x plus sigma y plus sigma z are 0, suppose sigma x and sigma y are 10 and 10 in tension, so 10 plus 10 is 20, and sigma z is compression minus 20, so plus 10 and minus 20, it becomes 0. So volume, that body's volume will not going to change. Suppose mu is 0.5, rubber or perfectly plastic material. So mu is 0.5, then again 1 minus 2 into 0.5 will be 0, like this. Okay, now impact loading sir will tell you. One more thing guys, let me tell you, suppose thermal stresses due to a bar, if it is fixed here, and if you increase the temperature, okay, suppose length is L, coefficient of thermal expansion alpha, temperature is increased by delta T. So if temperature is increased, it wants to increase. If temperature is increased, it wants to increase. Okay, but as it is fixed, so it will be compression. Stresses are coming in compression because delta cannot be there, it is fixed, delta will be 0. So in this case, sigma is given by E alpha delta T. Sigma is given by E alpha delta T. If the temperature is increased, stresses will be compressive. If temperature is decreased, stresses will be tensile. कोई और फॉर्मूला छूट रहा है क्या? अच्छा, ये इसके बाद composite. Suppose temperature is increased and suppose alpha 1 is greater than alpha 2. Suppose alpha 1 is greater than alpha 2. So actually if they were free, there is no restriction on them, they were free, it wants to increase up to here and it wants to increase up to here. If they are free, both will increase because temperature is increasing. Both will increase because temperature is increasing. Both will increase. But as they are composite, what I told you, composite का मतलब fixed means delta 0. Composite means delta same. If they were free, since alpha 1 is more, it will be elongating more if it was free. But now delta will be same. आपसे समझौते से they will move somewhere around here. So this will be in compression. It will push it from here to here, and this will be in tension. Okay, because it wants to elongate here, but it has to elongate up to here. So this will be tension. Okay, now suppose I say this P. So this. Oh. मिट गया क्या? वेट सर, ये बार बार डिलीट हो जा रहा है. धीरज सर ने कुछ वायरस ले आया क्या?
सर आप मुझे मौका नहीं दे रहे हो इसलिए।
सर बस SFD BMD तो 5 मिनट का, उसके बाद इम्पैक्ट लोडिंग से और फिर थर्ड सर। See, after this I'll tell SFD BMD, then sir will take impact loading, bending stress, then I will take shear stress, then sir will take principal stress and torsion, then I will take
Deflection.
shear center, and sir will take, and I will take deflection. उसका सोचते हैं। Okay, so composite means delta will be same. अरे ये ऐसी की तैसी। Composite means delta same. If temperature is increased, suppose alpha 1 is greater than alpha 2, if they were free, no restriction, it wants to increase up to here and it wants to increase up to here, but as they are composite, so they cannot elongate differently, they have to elongate same. Of course they will be elongating here also. For better understanding, I am showing just only one side. So they will elongate up to here. So this will be compressed from here to here, and this will be elongated from here to here. Suppose this is P, so internal force, this will also be P, summation Fx 0. Now, this is L alpha 1 delta T, and this is L alpha 2 delta T. Now, this is delta 2, and this is delta 1. Now delta 1 plus delta 2, delta 1 plus delta 2, this and this. So this summation is this minus this. So L delta T alpha 1 minus alpha 2. Delta 1, delta 2 plus delta 1 is this minus this. Okay. So 1 is this. And what is delta 1? Delta 1 is coming due to P force, PL by A1 E1. What is delta 2? PL for A2 E2. Because this delta 1 is, this P is pushing from here to here. This P is pushing from here to here. Because delta has to be same. So is equal to L delta T alpha 1 minus alpha 2. Okay. Like this. Like this. From here, one equation, one unknown P. You can find P, then stress in 1 is P by A1, stress in 2 is P by A2. So this is the case. And here, of course, when temperature is increased, the material having the larger alpha, when temperature is increased, the material having the larger alpha comes in compression, and material having the lesser alpha comes in tension. When temperature is decreased, it will be vice versa. You can think like, suppose Alia Bhatt and Ranbir Kapoor starts a camping from here. If there is no bonding between them, then Ranbir Kapoor has more stamina, it can go up to here. They are tracking. They start from the same place, tracking in a mountain. Ranbir Kapoor can go up to here if he was free. And if Alia Bhatt is free, having less stamina, she can go up to here in one day. But night both will stay together. So, they will not sleep in different tents, na? Shear aa jayega. So they will stay together. So they will here. So having larger stamina, having larger alpha is in compression. Having larger stamina will restrict himself, compress करेगा अपने stamina को, and आलिया भट्ट थोड़ा push करेगी, tension लाएगी. ऐसा भी याद रख सकते हैं. सर मेरे को अब ये बताइए, वो E G mu के का रिलेशन हो गया, डेल्टा हो गए सारे, PL by AE और 4PL by D1 D2 लॉग वाला भी, सेल्फ वेट और थर्मल स्ट्रेस का E अल्फा डेल्टा T.
थर्मल में स्प्रिंग रह गया था.
थर्मल में स्प्रिंग भी अटैच हो जाता है जब, वो भी स्प्रिंग वाले में करा देंगे. और उसके अलावा
हो गया था.
बाकी SFD BMD में देखो, इसमें कोई सेकंड चैप्टर है, इम्पैक्ट लोडिंग का सारा भी बता देंगे आपको. सेकंड चैप्टर SFD BMD में कुछ फॉर्मूला, एक भी फॉर्मूला नहीं है, एक भी फॉर्मूला नहीं है. बस आप ये कर सकते हो कि शियर फोर्स इज dm by dx. ठीक है. लोडिंग, लोड इंटेंसिटी, शियर फोर्स का डिफरेंशिएशन. सो यहां से एक चीज पता चल रही है कि इफ लोडिंग डिग्री इज n, तो शियर फोर्स डिग्री विल बी n+1, क्योंकि डिफरेंस आफ्टर डिफरेंशिएटिंग डिग्री इज रिड्यूस्ड बाय 1. सो if the degrees of this is 2x square, what is the differential of x square? 2x. What is the differential of x cube? 3x square. So after differentiation, degree is reduced by 1. Suppose the m का degree was n plus 2, then after differentiation degree will be n plus 1. So this is n plus 1. If this is n plus 1, after differentiation degree will be n. So anything which have a linear loading will be quadratic SFD and cubic parabola BMD, and similarly like others also. Okay. One more thing. All symmetrical supports, if a question is symmetrical support and symmetrical loading. Symmetrical support, symmetrical loading. So SFD will be anti-symmetrical. SFD will be anti-symmetrical and BMD will be symmetrical. Okay. Whenever shear force is 0, so bending moment there is either maxima or minima. Obviously, when shear force is 0, when some slope dy by dx is 0, then y is either maxima or minima. If shear force dy by dx is 0, that point either this is maxima or minima. Where bending moment changes sign, that is contraflexure. Why it is important? Suppose this is a beam. Bending moment changes sign. Here positive, here negative. Positive means sagging. Negative means hogging. So as I told you that brittle materials are weak in tension. Suppose a beam is made from concrete. It is weak in tension. So this is positive means tension will be coming here. This is negative means tension will be coming here. So deflected shape will be of this beam sagging and then it will be hogging something like this. So here tension is bottom. So reinforcement has to be put bottom because concrete is weak in tension. So we have to put reinforcement here. So here tension at top. So we have to put reinforcement here. So that is why the significance of contraflexure. The contraflexure site engineer will get to know that where he has to reverse the direction of reinforcement. Here bottom, here topward. This is contraflexure. So in bending moment, that point is contraflexure, and the same point in deflected curve where the curvature is changing. Because here it is sagging and then hogging. Same point in the BMD is inflection. Okay. So in SFD BMD chapter, guys, actually there is no formula. Area of loading diagram is equal to load. If there is a UDL, UVL, trigonometric load, parabolic load. Okay. So that will be the area of loading diagram will be total load. Tapered bar का कुछ नहीं है, PL by AE को तो 2-4 बार लगाना है भाई. Tapered bar में क्या है? ऐसा है, ऐसा है, ऐसा है. Suppose this is P1, suppose this is P2, and suppose this is P3. So delta we have to find out. Suppose this is 1, 2, 3. So total delta is equal to delta 1 plus delta 2 plus delta 3. So cut delta 1 will be cut a section here. Either see from top or bottom. Top करोगे तो reaction में देख लेना. So from bottom P1 is going away. Cut a section here. P1 is going away. So tension P1, L1, A1, E1. For delta 2, cut a section here. See from top or bottom, your choice. I'm not seeing from top because we have to calculate reaction. So bottom P1 going away from my head, P2 coming inside, going away, tension coming inside, minus. So P1 minus P2 into L2.
I feel he was talking about taper bar in thermal.
Taper bar in
thermal stress.
ओके ओके. अच्छा इसका आप कर रहे थे तो ये इस तरीके से हो जाएगा. डेल्टा 3 इज इक्वल टू सी फ्रॉम बॉटम P1 गोइंग अवे, P1, P2 कमिंग इनसाइड माइनस, P3 आल्सो कमिंग इनसाइड माइनस इनटू L3 A3 E3. ओके. स्पेशल टेपर्ड बार वाला के स्प्रिंग के इन थर्मल, अच्छा थर्मल स्ट्रेस में टेपर्ड बार वाला. ओके उसको भी पेल देते हैं. कहाँ कुछ जगह दिखे मेरे को थोड़ी सी, यहाँ पे करते हैं. ये वाली गलत है, ये तो मेरे को बताना ही पड़ेगा. हाँ ये मैं नहीं बता रहा हूँ, ये आप ही बताओगे. तो भर दोगे आप? नहीं इसको डिलीट कर देंगे ना सर, पहले वाला भी सारा डिलीट हो गया है. सी इफ द बार्स आर लाइक दिस and before coming to the thermal stresses, suppose this is R, indeterminate bar. Now you don't know A and B. So suppose reaction, any direction you can take. If it comes positive, my direction is correct. If it comes negative, my direction is wrong. So let it take RB and take it RA. So one thing, total left hand side force RA plus RB is equal to total right hand side force R. RA and RB are coming in left, RB going in right, so it is equal to same. Okay, one equation, two unknown. बहुत नाइंसाफी है. RA and RB are unknown. Now as both of them are fixed, so this is a delta AB is equal to 0 because A, B are fixed. So delta AB is delta AC plus delta CB. Delta AB is equal to delta AC plus delta CB. For delta AC, I just told you, cut a section here, C from left or right, your choice. So C from left, RA going away from my hand, away is plus. So RA, length of AC upon area of AC upon Young's modulus of AC plus delta CB, cut a section here, C from left or right, kahin se bhi dekh lo, let me see from right, RB coming inside my hand. So minus RB, LBC, area BC, EBC is equal to 0. Oh, samajh jao writing. Okay, so two equation, two unknown. So this is the case without thermal stress. Now remove this and suppose thermal is coming. नीचे आग लग गई. Delta T is increasing. So in this case, what will be happening that if reaction from here, it wants to increase, the assembly wants to increase because temperature बढ़ने से increase होगा. So there will be R here and summation fx 0. So here also R. So summation fx is equal to 0. This is R, this is R. Now, if there is no support, no fixed support, so both will increase. Suppose the length of this is L1, L2. So L1 alpha 1 of this material into delta T and L2 alpha 2 delta T. This is the case when there is no fixed support at either ends. Now, so this will increasing this much. But now this is due to temperature. This is due to temperature. But now R is also coming. So this is due to temperature. So due to R, cut a section here. It is coming compression. So minus R, L of 1, A1, E1. Now due to R, here, it is coming inside. Minus R, L2, A2, E2 is equal to 0. One equation, one unknown, find R. One equation, one unknown, find R. Once R come, R by A1 will be stress in 1, R by A2 will be stress in A2. I think simply support beam वाला केस इन थर्मल स्ट्रेस बाकी है ना, सिंपली वो ये
डिफ्लेक्शन वाला बोल रहा हूं,
LTH स्क्वायर वो ऐसा वाला, वो क्वेश्चन है भैया, कॉन्सेप्ट नहीं है वो, क्वेश्चन है, क्वेश्चन फॉर्मूला नहीं है वो.
वैसे भी वो डिफ्लेक्शन में
विनीत आप ये वाला बोल रहे हो क्या? ऐसे सिंपली सपोर्ट रहता है, टेम्परेचर यहाँ 0 था, यहाँ बढ़ जाता है, फिर ऐसा हो जाता है, ऐसा 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 वाला. विनीत वो क्वेश्चन है, मैंने करा रखा है यूट्यूब पे. नहीं ओके तो अब आएंगे धीरज सर, और आपको इम्पैक्ट लोडिंग का पेज चाहिए था, मैंने मिटा दिया सर, और धीरज सर कराएंगे अब आपको
बेंडिंग टॉर्शन.
टॉर्शन पे भी करा दोगे?
बेंडिंग करा दोगे,
बेंडिंग और इम्पैक्ट लोडिंग. ओके ओके सर, मैं अपना फोन ले लूं.
हाँ. सो गाइस, इम्पैक्ट लोडिंग का फॉर्मूला देखेंगे अभी. तो विनीत जो आप कह रहे हो वो डिफ्लेक्शन में है, और वो क्वेश्चन है, ये फॉर्मूला सेशन है, वो आप देख सकते हो. वो तो यार कितनी बार हमने यूट्यूब पे लिया हुआ है वो क्वेश्चन. ठीक है, चलिए. सो लेट अस सी अबाउट द इम्पैक्ट लोडिंग. तो आप सभी लोग जानते हैं कि व्हेनेवर वी आर हैविंग द लोडिंग, so it is going to increase from 0 to maximum value, and after that it becomes constant. And you know there is a time taken to become maximum, and if this time taken is going to be less than t by 2, then we call this loading to be impact loading. And this capital T is said to be the time period for phononical vibration. This is said to be the time period of phononical vibration. Now what is phononical vibration? So guys, you would be aware that, so guys, I am having some cold, that's why speaking slowly. So when we are talking about the phononical vibration, like if this is the body, in this the molecules are there at the room temperature, also they are vibrating, that is said to be the phononical vibration. So that is the case of impact loading. Now my dear, in impact loading you can imagine a W load is falling from a height of h onto this body. So when this will be falling, so obviously as it is falling from a height, it will be acting like a it will be acting like what? It will be acting like a impact load, because it is coming from a height, guys. So that is why, my dear, when this impact loading is there, then my dear, the stress is not going to be P by A. So the stress is going to be P by A when the loading is static, which what we are saying is gradually applied loading. So guys, we will be having the impact loading as the static loading into impact factor.
Okay, and my dear, whenever we are talking about the impact elongation, that is also defined as sigma I L upon E. So that will also be equals to the delta static into impact factor. Now, my dear, we are going to have two types of question on impact factor. So guys, whenever we are talking about the impact factor, it is given as 1 plus square root of 1 plus 2h divided by delta static. Here, what is delta static? Delta static is PL by A. Okay, so P is W here, so WL by A. So guys, here the one question will be coming on to that impact factor is depending on which parameters. So you can see that impact factor is going to be directly proportional, or you can say is a function of, it is a function of height. Yes, it is a function of delta static. Delta static means PLAE. So it is a function of P, function of L, function of A, function of E. So guys, the very first question will be coming in the exam, where they will be asking that whether this impact stress or impact deformation, that will increase or decrease by increase of H, by increase of load, by increase of length, by increase of area, by increase of Young's modulus. So you need to see which parameter is numerator, that will increase, and the parameter which is in denominator, that will result into the decrease of that. And second question, they may ask you the minimum value of the impact factor. So you know that when H will be 0, then you will be having the impact factor equals to 2. So the minimum value of impact factor is going to be 2. And my dear, this is the case which is said to be the this is said to be the what? This is said to be the dead load or suddenly applied load. Dead or suddenly applied load. And my dear, when we say dead or suddenly applied load, this is said to be the load like this. Okay, suddenly applied load. So it is the load which is having the, you can say, 2 times stress as that of the static loading. Okay, Vineet is asking, actually 2022 में क्वेश्चन पूछा था एक्सी में और 2023 में क्वेश्चन आया था उसी फॉर्मूला से, तो बिल्कुल आया था। और विनीत, जैसा मैंने कहा, अगर हमें करना भी है उसको तो हम डिफ्लेक्शन में देख लेंगे, बट वो क्वेश्चन है। और वैसे आप देखना चाहो तो आपको शायद याद होगा, फॉर्मूला इज अल्फा डेल्टा टी एल स्क्वायर अपॉन 8h। तो आप चाहते हो तो मैं लिख देता हूँ, ठीक है। तो फॉर्मूला अगर आप चाहो तो मैं यहीं पे लिख देता हूँ, इफ यू वांट, दैट इज अल्फा डेल्टा टी एल स्क्वायर अपॉन 8h। दैट इज द फॉर्मूला फॉर द डिफ्लेक्शन फॉर दैट केस व्हाट यू आर सेइंग। एंड हियर अगर हम बात करते हैं तो ये जो h है ये हाइट है, डेल्टा t जो है वो टॉप और बॉटम फाइबर का टेम्परेचर डिफरेंस है। दिस इज द टेम्परेचर डिफरेंस फ्रॉम टॉप टू बॉटम फाइबर। इज इट क्लियर? तो आई फील आपकी इतनी इच्छा है तो मैंने फॉर्मूला लिख दिया है, ठीक है। तो डेरिवेशन अब देख नहीं रहे, डेरिवेशन आपको देखना हो तो वो किया हुआ है किसी ना किसी सेशन में, आप देख सकते हो। इज इट क्लियर विनीत? आई फील यू गॉट इट। सो गाइस, ये था मामला कौन से चैप्टर का? इम्पैक्ट लोडिंग का। So guys, actually I have some cold, that's why I'm taking less chapter here only. So let us see now the next topic, that is bending. And in the bending also we will be having some formulas, not big formulas. Okay, so we are having this bending. So sir have told you wonderful things in the first chapter I have seen, and that is definitely going to help you. Like sir have also discussed an interview question also, where sir have told you where we will be using the reinforcement. Okay, so where we will be adding the steel rods, because concrete brittle material, not good in tension. So that kind of question is going to help you in the interviews. So guys, now we are talking about the bending chapter. So first of all, you must be aware that whenever we are going to have a beam like this is going to be the longitudinal axis. And guys, if you are going to make the cross section of this, then my dear, you know this axis we will be giving the name of neutral axis. And you know that this is the width of this is the height of the, you can say height, or you can also show it by D. So guys, this is the length of the beam, and you are going to apply the moment like this. You can see this moment is said to be bending moment. It is going to bend the body like this. Okay, so this is the bending moment. Bending moment is going to act like this. And if you want to feel it, sir, thermal stress with gap bata dijiye please. Okay, Saurabh, that also we will see, but first let me complete the bending topic. So my dear, if we have this bending, you know that in this case top fiber will be under compression, bottom will be in the tension. And if you want to see the 3-dimension view, so I would like to clear you, give you clearly the idea. So if a force is acting like this and like this, then my dear, you know this kind of bending moment, this kind of moment is said to be bending, and it will be creating the normal stresses into the body. And guys, this axis is said to be the neutral axis, which is always coming in the
cross section. You can imagine neutral axis is an axis which is always found in the cross section about which the bending couple is going to act. And guys, the bending stresses are always normal in nature. So if you see the formula which is coming is bending stresses divided by y. And if you want to write the maximum stress, then you can also write sigma b max divided by y max. Okay, and that is equals to m upon I is equals to E upon R. This is the formula, my dear. And I feel everybody would be aware that if you want to find out the bending stress at any fiber, you would be writing it as my upon INA. I is always about neutral axis. So for our case, INA will be BD cube by 12 or BH cube by 12. Okay, this is going to be the case. So guys, if you want to find out the maximum stress, no issue, Vineet. You asked me, I told you, okay. Ultimate aim is to make you guys happy. Some of you were also talking about engineering mechanics. I would like to tell you guys, I'm going to start engineering mechanics on the BYJU'S exam prep app. And there, if you will find that those sessions are useful, then tell me that. If you will find them useful, I will be coming for YouTube, the complete engineering mechanics course also. Okay, because I want to make your basics strong. And I know engineering mechanics is the problem, is a nightmare for many of the students. So I can tell you that if you find those sessions helpful, then you just tell me in the Telegram. I will be coming up with a complete subject and you will love it because it is going to make your basics. Okay. So guys, now we are talking about this BD cube by 12. This is My by INA. So guys, if you want to find out the maximum bending stress, then it can also be written as bending moment divided by ZNA. Here ZNA is the section modulus. That is section modulus because it is defined as INA by Y maximum. So guys, many students are using the Z terms for any stress. No, it is defined only for the maximum bending stress because here in the denominator we have Y maximum. So guys, this is said to be the section modulus. And you can also say that this term is also telling us that how much a beam is strong in the bending. Actually, this ZNA, I also call it as the strength of the beam under bending. It tells us about the strength of the beam or immunity of the beam for the bending. Like, you know, when COVID came, those people who were having good immunity, they didn't affect from the COVID. And many people passed away because they were having poor immunity. So likewise, my dear, immunity for bending is ZNA. If a beam will be having more ZNA, the stresses induced will be lesser. Okay. So the same COVID fever have made some people died and some people have faced it even at big ages. Why? The reason was immunity. The people who were having young ages but not good immunity, they died. So guys, the point is, whatever the stresses we are writing here, these are the stress induced. It is independent of the material. Whether you take a concrete beam or you take a steel beam, you will be having the same formula for the induced stress. Yes, capability obviously will be different, but the stress is independent of the material. Okay, stress is, you can see here there is no factor which is telling us about the material. You may be saying, sir, Young's modulus is there. So I would also like to add one thing here, guys, that whenever you are using okay, I'm telling here only, whenever you are using sigma B is equals to EY by R. So guys, this formula is used only for the case of when R is known to us. Because my dear, here you may be thinking that E is Young's modulus, it is depending on the material, but this formula we will be using when R is known to us, because guys, this ratio, if you see, the strain is defined as Y divided by R. So guys, you must be aware that strain is directly proportional to Y to the power 1, and by Hooke's law, stress is directly proportional to strain up to elastic limit. So we can say stress profile, strain profile is going to be linear with respect to Y. So whenever we will be having a beam like this, my dear, and if you are going to have a bending moment like this, then my dear, the distribution for the bending stress will be coming like this. Are you getting it, guys, properly? Yes, this is going to be the case. Now I am talking about the beam of uniform strength. So my dear, whenever we are talking about the beam of uniform strength, that is a beam for which the bending stress is going to be constant. If the bending stress is going to be constant throughout the length, it is not at all a function of length, then we will be calling this beam as a beam of uniform strength. We will be calling this beam as a beam of uniform strength.
Is it clear for everyone? Please tell me that. Yes. Okay. Sir, what doubt dB cube by 12 कब लगता है? Dear, look, if you are having this beam like this, Pagel word, do you have any doubt? Then please ask. If you are going to have, let us say one force is acting here, other force is acting here, then bending moment will be acting about this axis. In that case, I will become, this will become neutral axis and I will become dB cube by 12. Everybody got it? I have taken all the doubts. Yes. Everybody got it? So guys, Vineet, I feel it is clear. Pagel word, if you have any doubt, please ask. Okay. So let us move further, guys. I feel I went to the previous page. Okay. Okay, fine, guys. Let me go to the empty slide. We have completed the bending stresses. So, guys, any doubt? If in the bending stresses, please ask. Then we are moving further. Okay. So, I would also like to discuss the beam of uniform strength case. Like, let us say whenever you are going to have a beam like this, and we are going to apply the bending moment. Okay. So guys, if we are having this, the bending stress is going to be, you know, that M upon ZNA. Okay. M upon Z. So if you are taking any section, my dear, bending moment is going to remain the same. And also the Z value is also going to remain the same. So my dear, for pure bending case, you will be having M to be constant, Z to be constant, sigma B to be constant. So this is the case always when the beam would be of beam of uniform strength. But my dear, in place of this, if you are going to have this shear force, or if you are going to have this UDL, then my dear, you know, whenever you would be writing the equation for bending moment, it will be variable. Like here, bending moment is going to be minus P into X. Okay, and here bending moment is going to be minus WX square by 2. So here bending moment will be the function of X. So if that is variable, you want bending stress to be constant, Z also have to vary. So my dear, for such cases, you just need to equate the bending stresses of two sections and you will get to know that what should be the variation of the area. I feel for this case, everybody would be aware that if we are going to consider the depth to be constant, then you would be aware that width is going to vary linearly and we are going to write the variation as equals to Bxx is equals to B into X divided by L. Similarly, my dear, if you are going to consider the width to be constant, then depth is varying like this and the formula for that is coming out to be D root X by L. So this is the completion of bending stress. Now I will call Abhinav sir for the shear stresses. Okay, and then I will be coming for the principal stresses chapter. So this is the shear stress. So sir, please continue with this. Okay, so now the shear stress distribution. Before going to any formula, me and Dheeraj sir want to announce some news about the GATE site. GATE website has been launched yesterday, but after 20 or 25 minutes, we are about to take a session. Important announcement. Okay, we are about to take a session on that, but again the website is closed. But when website was opened, we have seen certain things that we will be telling you. GATE 2000 official website. Official notification. So yesterday, guys, we were waiting too long, but website was not. Thumbnail was also made. We can take the session that time also, but we want that more realistic situation. The पीछे बच्चों को दिख रहा हो, then we'll be taking. So it will be coming from 24th or 22nd August? 24th. 24th August. This time you can apply from this date, not the 1st September. 29 papers were is the last year also. This time one paper is added, that is data science and artificial intelligence. That is, you can take in the second paper. Now, whatever the paper combinations we have seen up to that time, for mechanical students, they can give the paper. For civil engineering, we have not seen that was it option or not.
So I would like to say, sir, for mechanical, previously we have Axial and PI. Now also this is.
This also there. 24th August, fees was also increased now, I guess 1800 or something.
हाँ sir, fees 100 rupees बढ़ी है.
Fees was increased
100 for general, for others 950.
Okay. एक ये देखा था सिलेबस जितना हमने तब तक देखा था up to when the site was open. Syllabus no change.
हाँ.
Syllabus was no change. And one more thing we have seen that the dates na sometimes some students do some minor error. So or some students don't fill the form. So after some time you can again fill the form, but with a higher fees. So that period was earlier only for 7 days, but now this time it was for 14 days. और भी कुछ देखा था सर क्या?
बस सर ये इस बार थोड़ा सा समय ज्यादा दिया है भरने का. 24th August to 7th of October you can fill.
7th October. And one paper was added. No syllabus changed. Okay. Whenever the site will be coming, guys, let me tell you, we will be the first one to tell you the complete information when we can show you the website. Otherwise, these details what we have seen yesterday, that we are telling you.
Actually, we wanted to come up with the complete details so that we can show you also. They have made the tabs, but all the tabs were not opening actually.
Yes, yes, Vineet, एक बार धीरे सर अपने ID देना.
Yes, Vineet, you can share me. Even you share me in the Telegram channel.
हाँ. Telegram नहीं.
I will be sent the mail ना. वो Telegram कर.
अच्छा हाँ.
You send me the Telegram, then I will share.
Okay, civil का भी है क्या? Okay, so that we will be telling again. The website will be there. Okay, now, guys, before telling you the shear stress distribution, let me tell you what is actually shear stress distribution. Guys, sometimes in offline, I was associated with the offline institute earlier before joining here. So sometimes my classes in Bhopal and Indore was in the same day, morning Bhopal, evening Indore. So that distance is exactly around, let me take 200 kilometers. And suppose the driver of the coaching institute takes 5 hours. So average speed is 200 by 5 is 40. But at every point of time, the speed is not 40. Sometimes 0 also, sometimes 120 also, sometimes 130 also, sometimes 140 also. So that is the average speed, not the actual speed. Similarly, suppose this is a beam. And at loadings also, some loading is also there. Suppose at a particular cross section, shear force at this section is, suppose, let me take S, and the cross section is suppose rectangular. So shear stress is equal to shear force upon area. But this is the average shear stress. Actual shear stress is not this. This is shear force for this whole section. The shear force is S. And area, whatever the area will be there. So shear force by area will be the actual shear stress. Shear force by area will be the actual shear stress. Oh, sorry, will be the average shear stress. What is actual shear stress? That is given by this formula. This formula says that the actual shear stress at any point is S AY bar by IB. Now what this means? Suppose I want shear stress distribution in this section. Okay. And this is the neutral axis. Neutral axis is the centroidal axis. Suppose I want shear stress at this T location. Okay. Actual shear stress at T. The whole section, the average shear stress is shear force by area. Simple. The actual, now we cut the section is like this, and we want shear stress at T point. Now shear stress at T point is given by shear force at that section into AY bar. What is AY bar? Area is area above that point. Similarly, if the point is below, so area will be the area below that point. Suppose we want T, so area above that, that is A. What is Y bar? Y bar is that from neutral axis, suppose center of mass is here. So center of mass of that green area, that is Y bar. So S is the shear force at that section, A is the area above that point, Y bar is the whatever the area above that point, uska center of mass kahan hai? I is the moment of inertia about the neutral axis. B is the width at that section. So here the width at every section is B. Now once we do this, once we apply this formula, always for a rectangular section, or we do for rectangular, triangular, circular, always the shear stress comes when we derive this. It is 0 at top and bottom and parabolic in between. 0 at top and bottom and parabolic. 0 at top and bottom and parabolic. That is the actual shear stress. That means the shear stress, see this shear stress na, shear force by area, S by area is the average. But actual shear stress is this. That means here the shear stress is 0. Here the shear stress is a little bit less. Okay. Here the shear stress is a little bit more. Okay. Here the shear stress is something like this. Like this. And tau max in rectangle is 3 by 2 of tau average. What is tau average? Shear force by area. Shear force by BD. Tau max here also is 3 by 2 of tau average. And tau max here is equal to 4 by 3 of tau average. Okay. For rectangular and for triangular, the shear stress is 3 by 2 of tau average. And here it is 4 by 3 of tau average. Here the shear stress X, the maximum tau max is at neutral axis. Here also the tau max is at neutral axis. And here the tau max is at mid depth. Mid depth. That is, if the total height is h, it is h by 2. H by 2 is not the neutral axis. Here the tau max is at neutral axis. Neutral axis is also mid depth. Here also it is neutral axis, which is mid depth. But here it is at mid depth, but not neutral axis, because neutral axis is at 2h by 3. Neutral axis from top is 2h by 3, but tau max is at h by 2. Got it, everyone? Okay. Now, suppose this is I section.
The syllabus I said.
In mail? Civil ka ki?
Mechanical, Axial or BI.
Okay. Now, the shear stress here, shear stress has rule. It will be 0. When you apply, this formula is applicable for any section. This formula is applicable for any section. When you apply the shear stress, it is 0 at top and bottom, then it is a parabolic variation, and here the area is reducing. So stress will be suddenly jump like this. Suppose I want the shear stress for T section. So from this formula you apply, it will be 0 at top and bottom, then parabolic variations, and area is reducing. So stress increasing. Now see, bending stress, I section is very good. That is why railway tracks are I. Because bending stress are maximum at top and bottom, and here the maximum area is top and bottom, so good. I section is good for bending. I section is very poor for circular, because where there are more stresses, it is less area, very poor. And where there is minimum stresses, there is maximum area. So what is economy of this section? Very poor. But for shear, it is vice versa. Where the shear stress is maximum, their area is maximum. Excellent, yeah, very good. And I section is very poor for shear. Because where the shear stress are more, area is less. Although it is good for bending, because in bending stress are more at top and bottom, so more area, good. But poor for shear, because where shear is more, area is less. And this is the tau 1. Tau 1 is the shear stress in flange. This is the junction. Just above the junction, shear stress is tau 1. Just below, it is tau 2. So just below, area is less in the web. So tau 2 by tau 1 is B by B. So B is this and small b is this thickness. Got it? Okay. Now, before going further, let us show you the mail of the syllabus. सर नहीं आया, चेक कर लो, इसमें भेजा ना बायजू की आईडी में, रिफ्रेश करता हूँ, चेक करता हूँ बेबी. Okay. So now sir will be taking principal stresses and torsion, then we'll be doing the other chapters. Okay? Yes. Okay.
So guys, now we will be starting with the principal stresses, which is a very important topic.
Okay. So let us see that.
Yes, Vineet, I have seen, even I got PI syllabus as well. So now we are moving for the principal stresses formula. So guys, when we are talking about the principal stresses, first of all, we need to understand that there are three things which generally we have. What are those three? One is the applied loadings, okay, applied stresses. Other is the induced stresses, okay, and third one is the maximum values. So when we are talking about applied, generally whenever you show any element like this, you say this is sigma xx, you say this is sigma yy, and you say this is tau xy. So these are said to be the applied loading. Okay, like let us say you went to the gym and you are going for the exercise, you are taking the dumbbells like this. So this is the applied loading. Okay, I am fine, Arun. How are you? So when we are talking about induced stresses, so my dear, whenever you are going for exercise or gym for the first time, you want to make body to impress someone, and you went to the gym, you are going for exercise a lot because you feel that if you will be doing excessive work on the first day, you will get body very fast. But guys, whenever you come back, then you will feel pain on the next day because your body was not habitual of that much load. So, but the pain is not coming at the places only where you have taken the load. It is coming on the joints also, at entire body. Many places you will be having pain here. Maybe even the that machines you have not touched from that part of the body, but still pain will be there. That is the induced value of stress. And guys, induced means like if I take any plate, on that plate some normal and some shear will be getting induced. And my dear, likewise there are many plates. This is the plate, this is the plate, this is the plate, this is the plate, this is the plate. So all the plates will be having some induced value, and out of those induced values some maximum value will be there. That maximum we are calling as principal. Principal word is used for both the extremes, maximum normal and minimum normal. But for shear we are calling it as maximum shear only. Okay, so that my dear, we will see now one by one all the formulas. So let us say sigma xx, sigma yy, tau xy are the applied loading. Then my dear, if you want to see induced loading at any plane which is at an angle of theta from the x face, then my dear, the formula for that is this: sigma xx plus yy by 2 plus sigma xx minus yy by 2 cos to theta plus tau xy sine to theta. Is it clear? Then if you have about the this is going to be sigma theta actually. Okay, then my dear, you would be having this is okay, that the same thing is there. Okay, then you are having this as tau theta. So this is at an angle of theta from the x face. Then my dear, you will be having xx minus yy by 2 sine to theta plus tau xy cos to theta. So that will be depending on what is the sine you have taken. Like if I have taken this sine, my dear, then the formula for that would be tau theta is equals to sigma xx minus sigma yy by 2 sine to theta, and you will be having minus tau xy cos to theta. So that will be depending that what side you have assumed. I have assumed this downward side. If you will be assuming upward, then this formula will be coming. Okay, so these are the formula for the induced stresses. Now we will see about the principal stresses as well. So when we are talking about the principal stresses, you know the maximum value sigma 1, 2 will be coming out to be sigma xx plus sigma yy by 2 plus minus square root of sigma xx minus sigma yy by 2 ka whole square plus tau xy ka whole square. And you must be knowing that where the plane of maximum normal stress is coming. Sir, shear failure के लिए best section कौन सा होता है? For that also we will see. First of all, I would like to tell you कि जब हम I section की बात करते हैं, वो bending के लिए best होता है. Sir, I have already told about the shear stresses. Shear stresses are coming maximum at the center. But there is a problem that whenever we are talking about bending, stresses and shear, both are coming. So we need to take the section like I section only, okay? But we will be designing the web part in such a way that it can bear all the shear stresses. Because generally the impact of bending is more because couples produces generally higher stresses. So when we are talking about 1, 2, this is coming like this, okay? Then my dear, this is the formula for principal stresses, and if you want to write down the plane at which the principal stresses or maximum normal stress comes, that is given by tau xy divided by sigma xx minus sigma yy by 2. Okay, this is the formula for that. And guys, if you want to write down the maximum shear stress, then my dear, maximum shear stress formula can be written as sigma 1 minus sigma 2 by 2. And also it is given like this: sigma xx minus sigma yy by 2 ka square plus tau xy ka square. So guys, anybody remember that in the terms of Mohr circle, what will be the name of this tau x? Mohr circle की term में इसको क्या बोलेंगे हम? What will be the name of this in terms of Mohr circle?
Radius.
sir. So guys, sir have already answered. So मैं लिख रहा हूँ. It is the radius of Mohr circle. It is the radius of Mohr circle. So guys, there is
विनीत साथ एक क्वेश्चन है मेरा.
हाँ.
मैंने अभी ध्यान दिया.
हाँ.
शीयर फेलियर के लिए बेस्ट सेक्शन कौन सा होता है? जनरली क्वेश्चन विनीत
हाँ,
इसको लाइट मोड में
safety
रखना.
के लिए,
हाँ, जनरली बच्चे पूछता है कि शेयर में सबसे अच्छा सेक्शन कौन है, सबसे मजबूत सेक्शन कौन सा है. आपका क्वेश्चन बड़ा इंटरेस्टिंग है. फेलियर में सबसे अच्छा बताओ.
तो फेलियर में अच्छा डक्टाइल ले लो कोई भी. डक्टाइल फेल इन शेयर. ओके गाइस, सो गाइस यहाँ पर मैं आपको एक वन मोर फॉर्मूला आई वुड लाइक टू गिव यू, and that formula is very special because last year also it have been asked that they can ask you the normal stress at the plane of maximum shear, because the shear stress at the maximum normal stress is 0, you know, because at principal plane shear stress is 0, but at the plane of maximum stress, so at tau max plane, they will be asking you what is the normal stress that I will be representing by sigma n or sigma star, and that is given as sigma xx plus sigma yy by 2. This is also the coordinate of the center of the Mohr circle, and it can also be written in terms of principal stress as sigma 1 plus sigma 2 by 2, because we know that the summation of algebraic sum of the normal stresses at any two perpendicular plane is going to be same. So guys, if you want to write one more thing for that I can write, this is going to be sigma xx plus sigma yy is equals to sigma 1 plus sigma 2 is equals to sigma theta plus 90 degree. So guys, this is a very important formula. So guys, now we have seen majority of the formulas. We are left with 1 to 2 more. That is, one is related to if we know the principal strain, then we can find out the principal stress how. But for that, I would like to tell you whatever the formulas I have written, they are for the stresses. If you want to write down the formula for the strain, then you just need to, you can say replace sigma theta, or you can say you need to replace sigma by epsilon, and tau you need to replace by gamma by 2. And also I would like to say one more formula, that is the plane of maximum shear. They would be coming out to be at this place. For that it is minus of sigma xx minus sigma yy by 2 divided by tau xy. I feel I need to add some slides. Okay, so I need to add some slides so that I can tell you all the formula and you can get all the formula in the PDF. So I am adding some slides here. Okay. Just wait. सर स्मार्ट बोर्ड भी मजे ले रहा है आज. Yes. So guys, let us go with that formula which I have written there. But it was tangent to theta is the plane of maximum shear xx minus yy by 2 divided by tau xy. Okay, and guys, then we are talking about one more formula that is related to the strains. So I told you, if you want to write any formula of strain, then my dear, you just need to replace that sigma by epsilon and tau by gamma by 2. Okay, when you will be doing that, you will get the formula for epsilon theta as epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 cos to theta plus gamma xy by 2 into sin to theta. So guys, then we would be having the epsilon theta by 2 formula. That is going to be epsilon xx minus epsilon yy by 2, and you would be having minus gamma xy by 2, and here you would be having sin to theta, and here you would be having cos to theta. Everybody know that formula? Then if you want to have the formula for the principal planes, it is coming out to be gamma xy by 2, replacing tau by gamma by 2, and you would be having here epsilon xx minus epsilon yy by 2. And you know the principal strains would be coming out to be epsilon xx plus epsilon yy by 2 plus minus square root of epsilon xx minus epsilon yy by 2 का whole square plus gamma xy by 2 का whole square. Is it clear for everyone? इंटरव्यू में ऐसे पूछे ये तो सेफ वाला बताना है तो गलत हो जाएगा. Sir, why 1 by 2 coming with tau? Dear, there is a reason behind that. Because whenever you are going to write, I'm telling you in brief actually, whenever I take the classes of the complete SOM, I give it in a great detail. So I will give you an idea for that, for the time. Like if you are talking about the normal strain, it is coming because of two components. Sigma xx से दो component होंगे. Whatever the epsilon xx will come, that will be coming because of two component. But do you know when shear is coming, it is coming because of four components. Why four component? Because this is tau xy, this is tau xy. So we have two components and other two are the complementary components, tau yx. So as it is coming because of four components. So my dear, total, let us say this is going to be the change of angle. So you can see phi here, phi here. So total, if I say that this is phi by 2, this is let us say phi by 2. So total change of angle is let us say phi by 2 plus phi by 2. Or if you want to write them in the terms of phi 1 plus phi 2, you can say this is the total. Okay, this is the total. Or if I normally write it phi only, why phi by 2? Then you will say the total angle is 2 phi. So this 2 phi is coming because of four components. So phi will be coming because of two components. So that is why as here four components are there, we write it gamma by 2. Not the gamma, because if four components are giving us 2 phi, two component will give us the phi. So four components whatever are giving is the total shear strain and two components will be giving the half of the shear strain. Everybody got the idea or not? Please tell me. I have tell you in a very brief, the same I explained for 30-40 minutes when I go for the class, and I will tell you when we will discuss complete SOM. This is only the formula revision session, so that's why I am not going into detail, but I feel you got a wonderful idea about that. Yes, great. So guys, don't worry, we will be coming for the complete SOM also. Sir, वो sigma theta का formula anti clockwise and clockwise कैसे consider करना है, please explain. So dear, I would like to say like whatever the direction I have assumed, if it is going to be that, then it will be the formula which I have written. If you will be going for this direction of sigma theta, this direction of tau theta, okay. So my dear, then the formula whatever I have written is going to be the right one. But if you are going to consider it in the opposite direction, then it is going to be opposite. So let us say if you are going to have any, let us say a triangular component is there. If any tau is going to be written like that, you just need to make opposite of that to the left hand side. You will get the direction of the tau. Okay, this is going to be the direction of the tau. So what is the direction here? It is anti-clockwise. Is it clear? But as I said, you just need to follow this. That is going to solve all your purpose. Is it clear? Am I correct, guys? Am I correct, guys? So 1 by 2 part is also clear to you? 1 by 2 part is also clear to you? Yes. Great. I found this in the Frank and White, which is the book of fluid mechanics. Yes, moving further, guys. So now we are talking about this is the principal strain. So guys, we can also write the formula for the gamma max. Gamma max by 2 is equals to epsilon 1 minus epsilon 2 by 2. Okay, this is going to be the formula for epsilon gamma max by 2, 1 minus 2 by 2. And we can also write it in this way. It is epsilon 1 minus epsilon xx minus epsilon yy by 2 ka square plus gamma xy by 2 ka square. So guys, these are the formula for the stresses and strain. Now, if you want to find out the principal stresses in terms of principal strain, sigma 1, you know that it is written as sigma 1 is written as E divided by 1 minus mu square epsilon 1 plus mu times of epsilon 2. Remember guys, sir 16 को पेपर है मेरा. This is helpful for me. Yes. You're welcome. Arun, 16 को कौन सा पेपर है डियर? 1 minus mu square epsilon 2 plus mu times of epsilon 1. So guys, now you would also be aware of there is a wonderful thing known as strain gauge rosette, because strain is a measurable term, measurable quantity. So we are going to find out the strain. We are going to measure the strain with the help of either strain gauge or strain gauge rosette. Strain gauge is an element which is having the size of a postage stamp, and we are going to put a copper coil, or nowadays we are using the chrome and karma. Nowadays we are using the chrome and karma. These are the material of the coil, and this is a bakelite bulb. So my dear, this is having a size of postage stamp, and this is a device which we are going to use as a strain gauge to measure the strain value. I am not going into detail because detailed session will be there. This is formula, so I am going directly for the formula. So when we are going to use 3 strain gauges together at predefined or predetermined angle, then the device is said to be strain gauge rosette. So when it is going to be strain gauge rosette, my dear, then I would like to tell you the formula for the rectangular strain gauge rosette. So you are having this as rectangular strain gauge rosette. Because for other we need not to remember the formula, we can directly use the equations. We have 3 strain gauges. One is at 0 degree, other is at 45 degree, other is at 90 degree. So we have 3 readings of the strain gauges. You know, strain gauge can only measure the normal strain. It cannot measure the shear strain. So we are going to know the strain which is epsilon 0 degree, the strain which is epsilon 45 degree, because these are the angle with the positive x-axis, and strain at the angle of the 90 degree. So we know these 3 values of strains. So my dear, if we are knowing about these 3 values of strain, I can write that the formula is epsilon theta is equals to, that was epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 cos 2 theta plus gamma xy by 2 sin 2 theta. So guys, when I was telling you the principal stresses, you must have seen there are 2 formulas. So one is for this anti-clockwise, second is for clockwise. Okay, but you need not to write that. As I said, if you want to go for clockwise, you just need to do one thing. If you are going to have, this is the plane which is making an angle of theta anti-clockwise from the x face. If on some day you are going to have a plane which is making an angle in the clockwise direction, just put theta in place of, just put minus theta in place of theta in the same formula. You will get the result like this. So you need not to remember this. If it is clockwise, just put theta is equals to minus theta. Everybody got it? So guys, sorry I went in between because I feel some of you may get confused. That's why I thought to tell you that. I wanted to skip it, but you guys asking me, so I told you. Otherwise you may be thinking sir would be not knowing that. Okay, so this is the formula we have. And my dear, we have 3 readings of the strain gauges. We will put one by one. So why I am going to derive it? I know the formula, I can write directly. But why I am telling you? Because if some other strain gauge rosette is given with some other angles, like here 0, 45, 90. Someday they give the angle like 60 degree, 120 degree and 180 degree. Sometimes they can give you the angle like 45, 90 and 180. Sometimes they can give you the angle like 0, 60 and 120. So they can give any 3 angles. We are okay with that. So guys, when you will be putting, first of all, epsilon 0 degree, you just need to put theta is equals to 0. You will be getting xx plus yy by 2. Xx plus yy by 2. Then my dear, you would be having cos 0 as 1. So xx minus yy by 2. Sin 0 as 0. So my dear, it will be coming out to be epsilon xx. Similarly, when you will be putting theta is equals to 90 degree, you will get epsilon 90 degree as epsilon yy. So my dear, 2 unknowns are known to us. Okay, these 2 readings we know. Now we will be putting theta as 45 degree, and then you will get the equation that gamma xy is equals to 2 times of epsilon 45 minus epsilon 0 degree minus epsilon 90 degree. So guys, with these 3 equations, we got epsilon xx, epsilon yy and gamma xy. So we got all the applied strain. Now you can find out the maximum normal strain, which is nothing but the principal strain 1, 2. It is having the formula xx plus yy by 2 plus xx minus yy by 2, and that is going to be cos 2 theta. Hello, sorry, this is not the principal strain. Principal strain is quite easier than this. It is going to be directly plus minus square root of xx minus yy by 2 का square plus gamma xy by 2 का whole square. So guys, what is the benefit of that? Now we got the principal strains here, and what is our target whenever we are studying strength of material? To get the design. And for design, we need the maximum value of stresses. Maximum stresses are either shear or normal. Normal are principal. So guys, we know the principal strains here. Now we will be going for the previously derived formulas of principal stresses. Here we need epsilon 1, epsilon 2, mu and E. When you will put it, you will get directly the principal stresses. And once you get the principal stresses, you can go for the design part. Wherever you study steel, machine design, so you can go for the design part. Okay. So guys, this is nothing but the completion of the principal stresses. Guys, please tell me, are you liking the session or not? Maja aa raha hai ki nahi? And do like and share the session. Still many chapters are there. And Abhinav sir will be coming soon for the other topics. Now I will go for one more topic that is related to thin pressure vessels. Okay. So for that, once again, I need to add 2 slides. And then after that topic, Abhinav sir would be coming again. So we are going for one more topic. Okay, guys. So we are talking about the thin pressure vessels. So I feel everybody is aware of that when we are talking about the pressure vessels, they are going to be of 2 types. One is thin, other is going to be thick. So when we are going to talk about the thin, then my dear, D by T ratio is going to be more than equals to 20. When we call it thin, it is D by T is going to be less than equals to 15. In between, we cannot say anything. So guys, when we have these formula for thin and thick, you know, thin and thick is also further classified into cylindrical and spherical shell. They are further either cylinder or spherical. But you know, in the gate, we have the syllabus of only the thin pressure vessels. So we will be having thin cylinder and thin cylinder and thin sphere. So my dear, let us write the formula for the thin cylinder first. I feel Pagel word have already given the formula. So you know, whenever we have the thin cylinder like this, let us say this is the thin cylinder I am making in the vertical format. So guys, let us say we are having this as thin cylinder. So when we have this thin cylinder, my dear, you know that we would be having the pressure inside is P. And let us say both the ends are closed, because if both ends will not be closing, then longitudinal stresses will not come. So guys, we will be writing here the values of the stresses. So you know, circumferential stress, which will be coming in this like this, which will try to increase the circumference. It is going to be PR by T. Or you can also write it as PD by 2T. Then my dear, what is longitudinal stress? It is PR by 2T or PD by 4T. Everybody remember that? Everybody remember that? सर आपको गेट 2023 की क्वेश्चन पहले से ही पता था, मैंने आपसे लास्ट ईयर पढ़ा था. यस ऐसा नहीं है, मुझे पता था, बाय चांस आ गया वो. लाइक सेम हैपेंड इन द मटेरियल साइज ऑल्सो. इन द मटेरियल साइज आई टोल्ड अबाउट द फॉर्मूला ऑफ द वॉल्यूम डेंसिटी. There also questions came for the first time. Last to that year also, just 3 days before, I have taken something from casting, that is slush casting and centrifugal. The question come from the centrifugal casting for the first time. It is not like I was knowing, it is just by chance, you can say God grace. Okay, so this is circumferential stress, this is longitudinal stress. So guys, after that we will be having the circumferential strain, sigma C by E minus mu times sigma L by E. So Vineet, thanks for remembering that you remember that whatever we have done that came into the paper. Sir, I have some query. Is there only English mode in BYJU? Why teacher is not teaching in English? Dear, actually we have pure English and English batch. Both are there. But in the YouTube session, when we are having these kind of session, we generally go for English so that every student can understand that. Otherwise, in the paid batch, we have English also, English also. Both are available. Okay, so guys, this is sigma C, sigma L. When you will be putting the value, you will be getting. Anybody remember PD by 4TE? 2 minus mu or 1 minus 2 mu? Anybody remember 2 minus mu or 1 minus 2 mu? 2 minus mu or 1 minus 2 mu? Vineet, Pagel word. Yes. Pagel word. Arun. Anybody? 1 minus 2 mu or 2 minus mu? So we are having PD by 4TE common. Yes, when you will be taking this as common, this is the sigma L value. So my dear, obviously here you would be having what? 2 minus mu. And then my dear, if you want to write down the longitudinal strain, it is coming out to be PD by 4TE. And it will be having 1 minus 2 mu. And my dear, you must be aware of the volumetric strain, that is 2 times of circumferential plus longitudinal. Is it clear for everyone? This is the volumetric strain. And I would like to tell you that last year, they have asked about the question that where they have asked about the change of thickness. So guys, this is the circumferential strain, this is the longitudinal strain. Okay. So if you want to find out the strain in the thickness direction, that is going to be what? That is going to be, you know that in the third dimension, we are assuming the stress to be 0 because it is the case of plane stress condition. So we would be writing minus mu times sigma C by E and minus mu times sigma L by E. And you will be writing this to be delta T by T. So you can also find the change of thickness. Okay. Stress we are assuming as 0 in the third dimension, but it doesn't give guarantee for the strain to be 0 because plane stress condition we are assuming stress to be 0. In plane strain condition we are assuming strain in the third direction to be 0. So guys, in the strength of material for thin cylinder chapter, we assume plane stress condition, and that is given like this: sigma C and sigma L. So sigma C is also acting like principal stress 1 and sigma L is acting principal stress 2. So if you see the Mohr circle of the thin cylinder will be coming like this. So next we are talking about thin sphere, and after that Abhinav sir will complete the rest topics. Torsion हो गया सर? नहीं सर. तो torsion 5 minutes लगेगी. Thin sphere. So thin sphere is sigma circumferential is, that is going to be PD by 4T. Okay, here only one stress, that is sigma circumferential. And if you want the epsilon C, it is 1 minus mu upon E into 3 into PD by 4T. And if you want to write, my dear, the volumetric strain, that is 3 times the circumferential strain. I would also like to add one more thing, like the tau maximum. Tau maximum for cylinder. Okay, you will be writing sigma 1 minus sigma 2 by 2. That is PR by T, PR by 2T. So it is going to be PR by 4T. So my dear, this is the in plane maximum shear. And if you want to find out absolute tau max for cylinder, it is going to be sigma 1 by 2, which is PR by 2T. Then for sphere, if you want in plane, that is going to be 0 because in sphere we have only circumferential. So circumferential minus circumferential by 2 is 0. You can say the sphere is this case of the, and you know, for this case, if it is sigma, it is sigma, it is sigma, it is sigma, Mohr circle is going to be a point. So as it is a formula revision, I am going slightly faster, I know. So if you find any doubt, you can stop me there. I can go into some detail if you want. Then my dear, if you want to go for the absolute tau max for the sphere, that will be sigma C by 2. It will be PD by 80. Is it clear for everyone? Please tell me that. Everybody understood this? Arey bolo bhai, aa raha hai ki nahi? So with this we have completed thin cylinder and thin sphere as well. Everybody got it? So do like and share the session, guys. Now we are moving to the pure torsion. So sir, please continue from this. So Abhinav sir is coming, guys.
Okay, dosto, how was the Josh? It's been, I guess, 2 hours.
फॉर्मूला में लिख देता हूँ क्योंकि वो विनीत पूछ रहा है. विनीत को सब फॉर्मूले याद है इसलिए पूछ रहा है. So volumetric strain, whenever we are going to write for the cylinder, is going to be PD by 4TE 5 minus 4 mu. This is for the thin cylinder. Okay, I feel this you was asking about. Yes. Okay, sir, over to you.
Okay. Torsion, आप बाद में लेंगे?
आप ही ले लीजिए सर. Okay. So guys,
the speciality of torsion is na, that if you study the first chapter, that is stress strain, and the third chapter, bending stress, then replacing P by torque and delta by twist, many of the formulas you can correlate. As SOM is deformable physics, with application of some P force, there is delta. In the same way, with torsion, like P is causing delta here, P is producing delta. In the same way, torsion here will be producing twist. The A section will go to A dash, B will go to B dash, C will go to C dash, and this is twist phi. Same for B, C and D also. Of course, this will not be rotating like a sugarcane juice machine. Okay, this will not be rotating like a sugarcane juice machine because it is fixed here. Also, it is not accelerating because it is fixed here. Now, if the cross section is like this, then as in bending formula, we have a torsional formula here. Tau by R is equal to T by IP is equal to G phi by L. Same like the bending formula, sigma by Y is equal to M by I is equal to E by R. In bending stress chapter, in bending, okay, we need thoda mera bhi तारीफ कर लो यार. Okay, so in bending stress chapter, this M is producing sigma. This is the sun and it is produced by M. Father is M. Similarly, in torsion chapter, shear stress is produced by the father, torque. Torque is the father. This torque, when I am applying a torque in this body, I am not compressing it, I am not elongating it. I am applying a torque, so there will be shear in this section. There will be a shear in this section. When I am applying torque here, I am not compressing it, I am not elongating it. I am applying a torque which is around this section. So this will be a shear. Now how much will be the shear that we will be getting from here? Now before going to this formula, let me tell you that what is the difference between bending and torque. Suppose this is a beam, then about these axes, these are the transverse axes passing from the plane only. These are the transverse axis which is passing from the plane only. So from the plane, if these axes, transverse axis, there is movement about these axes, transverse axis, that is bending moment. And if about this axis which is coming out, this is not the transverse axis, this is the longitudinal axis. If about this axis there is a movement, that is called as torque. Got it? Got it, friends? Everyone? Yes? Okay, Arun. So any movement about the longitudinal axis is called as torque. Now this torque will produce the shear stress. This is the shear stress at R distance from the center. R is the distance from the center. T is the torque at that section and IP is the polar moment of inertia. Now, suppose this is the section, then IP is about this axis. Okay, because the torque here, we are writing I about the transverse axis because movement is about the transverse axis. So therefore we write about the I about the transverse axis. Here we write IP because the torque is about this axis. So we write moment of inertia also about this axis. Okay, so tau is the shear stress at R distance, T is the torque, IP is the polar moment of inertia, G is the shear modulus, phi is the twist, L is the length. So from here, torque or shear stress is equal to T by IP into R. R is the distance from the center. So here at center, torque will be 0 because R is the distance from the center. At center, R will be 0. At center, R will be 0. So R will be 0. So torque will be 0. As we are going further, shear stress will be increasing. As we are going further away from the center, shear stress will be increasing. And for solid circular section, it is maximum when R is max. R max is the maximum distance from the center is D by 2. Maximum distance from the center is D by 2. Okay. So if we put IP value, that is pi by 32 into d ki power 4 and put this, then tau max is coming to be 16t by pi d cube. That tau max is for solid circular section, because IP I have written for solid circular section. For different sections, IP will be different. For hollow and all, torque will be coming differently. You got all this? Okay, so torque, shear stress is varying linearly with R. Okay, now this particular direction I have denoted for this kind of torque, because if this is the torque, then shear here is like this, and here the shear is like this, if this is the torque. If I put it here, if I draw here, then this is the torque. So at this portion, see my hand, at this portion, torque, shear stress will be like this, in this direction. And if torque is like this, at this portion, torque is like this. At this portion, it is like here. Okay? Have you got this? Have you got this? Everyone? Okay. Now, one more formula comes from here. If you see this and this, then T is equal to, or phi is equal to T into L by GIP. This GIP is providing torsional rigidity, like in delta is equal to PL by E. If you compare this with delta is equal to PL by AE, with more AE, delta is less. So with more GIP, phi is less. So GIP is the torsional rigidity and GIP by L is torsional stiffness. Give me yes or no in the comment box. Give me yes or no in the comment box, everyone. Everyone, please. Everyone, please. Please share the session, guys. Come on. Okay. Okay. Like this torque. So this is the twist. Okay. When we apply the torque like this. Okay. When we apply the torque, so there will be twist coming. Now power is equal to T omega. Now this is the case when a shaft is rotating with some angular speed. So power is T omega. Omega is radian per second. So somebody has given you N. N is the rotation per minute. So in one rotation, how much angle? In one rotation, how much angle? 2 pi. So in N rotation, how much angle? 2 pi N. In one rotation, it is 2 pi angle. So in N rotation, how much angle? 2 pi N. This is per minute. So per second, it will be 60. So omega can be also replaced here. T into 2 pi N by 60. Omega can also be written as 2 pi N. Because number of rotation is N. So in one rotation, it is 2 pi. So N rotation, it is 2 pi N. It is per second, radian per second. So making it per second by 60 because it is per minute. Got it? Now, moving to shear center. Shear center is that point through which if load passes, there is no twist. Shear center is that point through which if load passes, there is no twist. For finding the shear center, golden rule is it always acts on the symmetrical axis. So if there are two axes of symmetry, it has to lie here also, it has to lie here. This is the shear center. Okay, this is the axis of symmetry, this is the axis of symmetry. So shear center is this. If shear center always lies on the axis of symmetry. If there are two axes of symmetries, it will be on the junction. Now for these sections which are made of two narrow rectangle plates, shear center lies on the individual axis of symmetry of both the rectangles. When this is a rectangle plate, this is the rectangle plate. When there are two rectangle plates, shear center lies on the axis of symmetry of the two plates. Now, column I am telling, PCR critical load is n square pi square E, n square pi square E into I minimum, कुछ गलत हो गया ना इधर, pi square E I minimum upon L effective square. Okay, because guys, number of loops, you generally don't see this n square because if the figure is here, no, figure is not here. Suppose this is the column, then n is 1, loop will be like this, deflected shape. But we only study this, so n is 1 in our syllabus. But suppose here is also column, so due to load, loop can be 2 na. So in that case, it is 2 square. But in our case, n is equal to 1. N is equal to 1. So PCR is equal to pi square E I minimum upon L effective square. This is the load at which column will buckle. Okay. SF, BM, axial force, shear force, everything is internal. Internal, guys. What is internal force? Now, Rajshekhar, you can ask, which is obtained after cutting the section. If you cut the section, these are the internal forces coming. Now, why it is I minimum? Suppose this is a column. Okay. So, I about this axis can be there, this axis can be there. About both axes can buckle. Na? I can buckle like this also. I can buckle like this also. If I am a column, I can buckle like this also. I can buckle like this also. So whatever the minimum load will be there for buckling, if it is here, then this itne pe fail ho jayega, to iski naubat hi nahi aayegi. Because for this also there will be some PCR. For this also there will be some PCR. So we'll be considering the minimum load na. Ki ek baar bhi fail ho gaya, that will be considered as failure. So this we have to take the I minimum upon L effective. Now L effective for both side fixed case. L effective here is L by 2. When both sides is pin, L effective is L. When one side is fixed, another side is free, L effective is 2L. When one side is pin, other side is fixed. नीचे का दिख रहा है क्या? When one side is fixed, other side is free, it is L by root 2. Okay. So, now moving further. PCR for n is equal to 1 is equal to pi square EI minimum upon L effective square. Now, I minimum is also called as A into R minimum ka square. R is radius of gyration. What is the physical meaning of radius of gyration? Can anybody tell me? What is the physical meaning of radius of gyration? Can anyone tell me that? What is the physical meaning of radius of gyration? Physical meaning of radius of gyration is that if radius of gyration is more, see R is equal to under root I minimum by A. If R is more, that means for a particular area it provides more moment of inertia. If R is more, that is having a more moment of inertia, more stronger section it is. Okay, R is more, that means more I for a particular area. Now if I replace this pi square E, I can be written as pi square E into I minimum. A into R minimum square. Okay. So L effective by R minimum ka square, like this. And what is L effective by R minimum? I'm not getting you, Para. The distance from the center of mass of a body. What is LE by R minimum? This is lambda, slenderness ratio. So it is pi square EA by lambda square. Lambda is slenderness ratio. More is the lambda, that means it's a long column. More chances of buckling failure. Lambda is less, then it is a short column. Crushing failure have more chances. Generally for steel, if lambda is more than 86, 90, 100, 110, then it's long column. More chances of buckling failure. Now, we got from here that PCR is equal to pi square EA upon lambda square. So if somebody asks you buckling stress, sigma B. So buckling stress is force by area. So that is pi square E by lambda square. Got it? Got it? Okay. Now there is Rankine theory also. Although the 99% chance question will be coming from Euler. So Rankine load is saying that whatever is the critical load from Euler and what is the crushing load? What is crushing load? Sigma permissible into area. You find here that is the Rankine's load of failure. Now, so deflection. These are the formulas for deflection. For when M moment is acting, the deflection of the free end is ml by EI, or slope is ml by EI, and deflection is ml square by 2 EI. When it is a point load in the cantilever beam, deflection is PL cube by 3I or WL cube by 3I, and slope is WL square by 2I at the free end. When there is UDL, it is slope is WL cube by 6EI and deflection is WL4 by 8EI. When there is a uniformly varying load with W intensity at the fixed end and 0 at the free end, slope is at the free end is WL cube by 24EI and deflection is WL4 by 30I. And for this, no need to remember every standard result. Now for this, you can convert this as a UDL minus UL. This standard formula you know, this you know, and you can do. Of course, these are the standard formulas. That this formula is giving the slope only here. What if we want slope here? What if we want slope here? What we want? For then there are different theorems, moment area theorem, strain energy theorem. Okay, so there are some different theorems for that. Okay, so that of course we will teach you in deflection theorem only. So deflection is more about theorem, because standard results will give you the results at a particular location also. They will not give you the results at every location. For other location you have to find, you have to get it from the theorems that we'll teach in the class. Of course this is the formula marathon, that's why we are not going here. Okay, so sir और कुछ बचा है क्या?
सर उससे कंप्लीट कर देते हैं वो कॉन्जुगेट वाला, सॉरी कॉन्जुगेट नहीं,
एक स्प्रिंग बचा है,
स्ट्रेन एनर्जी मेथड बता देते हैं बस दो फॉर्मूलास में।
स्ट्रेन एनर्जी, अच्छा
डिफ्लेक्शन,
मतलब यार मैं बता दे रहा हूँ फॉर्मूला आपको स्ट्रेन एनर्जी का, पर बेटर है एक बार मेरा क्लास या सर का क्लास देख लेना, उसमें मैंने एक शॉर्टकट भी बताया है। उसमें मैंने एक शॉर्टकट भी बताया कि इतना जनरली क्या करते हैं कि आप यू निकालते हो m स्क्वायर dx अपॉन 2e से फॉर द होल बीम, एंड डिफ्लेक्शन फ्रॉम Castigliano's second theorem is partial differentiation with respect to load. Now this formula will only give deflection where p load is acting, and this formula gives the deflection in the direction of p load. If p is downward, deflection is downward. If this value comes in positive and p is downward, then deflection is in the direction of p. If this from this formula answer comes negative, then deflection is opposite that of p. And theta is del u by del m. But the limitation is that this formula gives the deflection only where p load is acting. This formula gives the theta only where m is acting. For other locations, if there is no load acting, we have to apply a pseudo load, and at the end we put pseudo load equal to 0. But I still recommend that this is a very long method. In strain energy method, I have given a very short method where you directly get the deflection. Okay, so deflection in my formula is bending moment upon del mx by del pn upon ei into dx. Similarly theta also. Please see my lecture. In this now, what you have to do, you have to first find u. Then you are finding delta. In my method, AN method, you don't have to find u. Directly this formula, short trick, will give you the deflection. But better understanding will be coming when you see that whole lecture. If you see strain energy methods of me and Dheeraj sir on the YouTube.
I feel sir वो लिंक अब शेयर कर देगी जो टोटल वाला था।
बिल्कुल। और स्प्रिंग में जब हम फोर्स लगाएंगे ना, when we apply the force on the spring, again that I told in the first chapter, strain energy is given by 32 p square. P is the force, r is the distance from here to here, n is the number of tons, g is the shear modulus, and d is the thickness. D is this thickness. So strain energy is 32 p square r cube into n is the number of ton, g into d की power 4. This is the strain energy due to p load, because when you are applying the load, you are doing some work na. Now Castigliano's theorem, delta is del u by del p. So del u by del p you will get 64p r cube into n gd4. Now stiffness is given by p by delta. If p by delta you do, from here it will be gd4 64 r cube n. From here you get k is inversely proportional to n. That means if the stiffness is k and if you cut the spring into equal parts, stiffness will be 2k and 2k. Because if we cut the spring, g is not changing, d is not changing, d is this thickness, r is not changing, n is only changing. So if n is half, if we cut the spring, number of tons will be half, stiffness will be double due to this. Now if the springs are in series, k equivalent is like this. Spring series का मतलब क्या है, physical मतलब क्या है? Spring का if they are series, that means all are having F force. And what is the meaning of parallel? The delta is same. If I apply the force, delta will be same. That is the meaning of parallel. For parallel formula is this. For series, the formula is this. For closed coil helical spring, strain energy, axial deflection, that I all told, k proportional to 1 by n. Spring index is d by d, that is there. So Telegram channel is civil by Abhinav sir, and for mechanical it is mechanical by Dheeraj sir. Our civil, sorry एक बार बच्चों को,
So guys, civil versus mechanical war have been started from today, but the sessions would be starting from tomorrow only. Today was just an introductory session on the app, so you need to join 5 p.m. every day, okay? And this is going to be for 8 classes, and in 8 classes we are going to cover a number of questions, okay? So in those 8 sessions, everyone have to maintain the attendance so that you get the prizes also, because top 4 students, okay, let us show you the let me show you the rules for this First of all, this would be taken on the app, so you need to join on the BYJU'S exam prep app. Then the second thing, guys, 4 winners on the basis of the cumulative score will be getting the prizes. Okay, so 4 students are going to win the prizes. You need to maintain the attendance more than 50%. Means out of 8 sessions, minimum 4 sessions you need to attend. They will be free sessions only, and they will be on the app. And after 8 sessions, we will be announcing 4 winners who will be getting the gift hamper from the side of us. Okay, so next is, guys, session duration will be 40 minutes. So every day you need to join us at 5 p.m. Like tomorrow, my session would be there, in which the topic will be simple stress and strain. Okay, or you can say stress strain diagram topic. So I will be coming up with some questions. It will be in the form of quiz. They will be MCQ type. And guys, every day your scores would be counted, and at the end we will give prize to the top 4 students.
Yes, this is free. It will be on app.
Yes,
it will be on app daily 5 p.m. Sir, आगे schedule भी
yes. So I am showing you schedule as well, so that you get an idea that how it is going to be. So tomorrow we have sir's birthday, so tomorrow sir will not be taking the class. So tomorrow I will be taking stress strain diagram, and we will be having the quiz at 5 p.m. for that. Then Abhinav sir would be taking on SFD BMD. Then I will be coming with bending stress. Then Abhinav sir would be coming with shear stress. Then I will be coming with principal stress or Mohr circle. Sir will be coming with torsion. Then I will be coming with column and thermal. Sir will be coming with slope and deflection. And after these 8 classes, we will be coming to announce the winner.
4 winners.
Or 4 winners for the civil versus mechanical.
They will get the gift
and
hampers.
we do this every year, guys. So I feel every year you guys are coming in huge numbers. We are expecting the same. So I would like to say, please tell about this to other students also, because more will be the number of students in this, more will be the benefit to you guys, because ज्यादा कंपटीशन में आपको पता लगेगा वेयर आर यू लाइंग इन द कंपटीशन. ओके, और बहुत शानदार क्वेश्चन होंगे. आप उन क्वेश्चंस की पीडीएफ को रख भी सकते हैं आपके एग्जाम की प्रिपरेशन के लिए. एंड गाइस, ऑल दोस टॉप 4 winners, they will be getting the prize as well as till the examination. You guys would be there in our guidance. Me, Abhinav sir, and those 4 students will be having a group where we will guide you until your exam.
Thank you, thank you, everyone. Thank you.
Okay, guys. So, sir, shall we complete here?
Okay.
So this is the workshop also on 8th of August, 7:30 p.m. Me and Rakesh sir would be coming, so you can join that as well if you are preparing for 2024.
MSQ. And scholarship test is on 6th of August, tomorrow. And this is the session how pillars are made in mortar. I'll take on Monday. And MSQ series also coming. कहाँ गया? From 8th of August, MSQ series also coming. Okay. For civil and mechanical both, all subjects will be done. MSQ series on YouTube, and this app free session is on. This free session is on app. Okay. Thank you. Thank you, guys. Take care.